So hello everyone, we are here for Math 110 and the title of this course is Differential Calculus and Coordinate Geometry. That means you can understand that we have two parts that are attached. These two parts are the two different fields. So we have one part that is differential calculus and we have another part coordinate geometry. So this is my very first session with all of you and I will try to discuss or hold the sessions in a way that you feel like we are in campus. So let's start. So you know that this syllabus is designed from week 1 to week 12. From week 1 to 8, you will be taught the differential calculus part. And from 9 to 10, you will see some contents from coordinate geometry. So week 1 to 8 in BUX, that is designed for differential calculus, and week 9 to 10 is designed for coordinate geometry. At the beginning, all the contents may seem abstract, but very quickly you will get used to them. Our first topic that we have in differential calculus is limit. So we need to know the ins and outs of limits, and then continuity is coming. So the first topic that we have in differential calculus is limits and continuity. So today we will try to discuss about limits and continuity. But before, I would like to mention you the classifications of calculus. So we know that calculus has two branches, that is differential calculus and integral calculus. So differential calculus can be found in Math 110 and integral calculus part will be in Math 120. So after completing successfully Math 110, you will be able to take Math 120 and there you will learn about integral calculus. So the whole syllabus of Math 110 is designed for differential calculus and some parts from coordinate geometry. So whenever the term calculus comes to our mind, you can think about the Greek mathematician Archimedes. So the idea of calculus was first introduced by Greek mathematician Archimedes. And then the main formulation of calculus was done by Sir Isaac Newton and Gottfried Wilhelm von Leibniz. So Isaac Newton and Leibniz mainly discovered calculus, and followed by them Leonhard Euler mainly developed today's calculus. We should have respect towards them because for the pioneers today we have the modern calculus that is known as differential calculus and integral calculus. Let me start from limits and continuity, but before we need to know about function. Let me go through about function in a very short way. So let's discuss about function. At first, you have to know the definition of function. So function is a relation between input and output variables, where for every input there must have one and only one output. So 1 and only 1 is also treated as exactly 1. So function is a relation between input and output variables where for every input there must have one and only one output. So now the term that is coming to our mind, what is relation? So relation between input and output variables. So variables are the letters A, B, C up to X, Y, Z. That means all the 26 letters can be treated as variables, which varies over time. So let's say we have X, Y, and Z as the variables. For now, we are using X and Y as the variables. So for simplicity, we often use X and Y as the variables out of the 26 letters. Let's say we have Y equal to X plus 1. So here we can input X, then it is possible to find Y. Suppose we are inputting 0, 1, 2, -1, -2 in this relation. So wherever we have X, let's input the values of X. So if we input 0 in the place of X, so 0 plus 1, we are getting 1. If we input 1, so 1 plus 1, that is 2. If we input 2, so 2 plus 1, that is 3. If we input -1, so -1 plus 1, that is 0. If we input -2, so -2 plus 1 is -1. So you can understand that the values of Y is totally dependent on X. So first tell me, is it possible to get Y without inputting X values? Is it possible?
No.
No.
No,
So
sir.
thank you. So first of all, we have to input the values of X, then we can expect the values of Y. So now suppose we are inputting 3. So whenever we are plugging 3, so 3 plus 1, that is coming 4. So 4 is the output. So here you can understand that we have two variables, namely X and Y. So we are inputting X, so that's why X is called the input variable. Variable are the letters. For simplicity, we are using X and Y as the variables. Now the term, what is input and output variables. So since we are inputting X, so X is the input variable and Y is the output variable. And you can easily understand that if we collect X and Y, X comma Y as an ordered pair, let's say you have X comma Y. Following this pattern, we can write this one as -2, -1, the second point as -1, 0, then 0, 1, 1, 2, 2, 3, 3, 4. So this is how we can go on. At first, we are writing X values, then we are keeping Y values. So this is called an ordered pair. So you can see that we have the relation between X and Y. We have the relation between input and output variables. So mathematically, input variables are called independent variable and output variables are called dependent variable. So easily we can understand that X is the input and y is the output, x is the independent variable, and y is the dependent variable. Why y is dependent? Because at first we need to input x, then we can expect for y. So that's why we can classify variable in two categories, that is input variable and output variable. So input variable means independent variable, and output variable is called the dependent variable. For function or relation, you will often see input variables are treated like domain. So you know the term about domain. And then output variable is also known as range. The values that you have for input variables that are called domain, and the values that you have for y that are called range. So input variables and output variables. So input is x, output is y. So whenever we have found x, y values, this is becoming a relation. So now we have understood that relation between input x and output y. So you can also think about set, x set and y set. X is the independent variable set and y is for dependent variable. So whenever we have two sets, we may have a relation. So that relation can be called a function if this condition holds. So where for every input x, there must have one and only one output. So this condition is very important. So all relation can't be a function, but all function is relation. Let me give you two examples. Let's say we have y equal to x squared and we have y squared equal to x. We want to understand that which one of these two examples is function. So we have to determine whether y equal to x squared and y squared equal to x are functions or not. So already we have the relation that is in between x and y, in between input and output, in between independent and dependent variables. So you can see y equal to x squared and y squared equal to x are our examples. So for now, we can easily say that these two are relation. But now our target is whether these two are function or not. So again, the same thing will be done. Let's plug some values of x and try to find the values of y. So that's why I am going to find the values of x and y. So that's why this tabular form is designed here. So with these two examples, we'll try to understand whether the examples are functions or not. So the term function is very important for differential calculus. You all are here for learning differential calculus and coordinate geometry. So without having the concept of function, you can't go forward. Okay, so that's why I'm starting from the very beginning. So let's input some values of x for this relation. So we are plugging 0, 1, 2, -1, -2, where we have x. So we can also rewrite this relation as y equal to x in parenthesis squared. This will be easier for us to calculate. So let's input 0 where we have x. So first we are going to plug 0. So 0 is squared is 0. If we input 1, we will get 1 because 1 squared is 1. If we input 2, so it will be 4. If we input -1, so -1 squared is 1. Or -2, -2 squared will be 4. So let's use this diagram so that we can verify whether the relation is function or not. So we have -2, -1, 0, 1, and 2. These are the x values we have taken. And for these values, we have found some y values. So y values can be written here. So let's write. So we have found 4, 1, and 0. 4, 1, 0, again 1, 4. So since 1 and 1, 4, 4 are repeating, so using set theory, we can just write 0, 1, 4. No need to write 1 twice or 4 twice. Okay, so here let's try to understand. -2. For -2, we have found the output 4. That means -2 is corresponding to 4. -2 is mapping to 4. -1. -1 is mapping to 1. 0. 0 is mapping to 0. 1. 1 is mapping to 1. If you are unfamiliar with the term mapping or corresponding, for you, I'm trying to say that corresponding means you have the relation in between x and y. So let's say for 1, which value you have found? For 1, you have found 1. So this is the correspondence. This is the relation. This is the mapping. For 2, so for 2, we have found 4. So this one. So from here, we can easily understand that whether this one is function or not. But let me draw in a nice way so that you can understand. So we have x and we have y. So same values are here: -2, -1, 0, 1, 2. But without writing like this way, I'm just writing in this form. We have -2 and 2. So why not we write in a group -2, then 2, then -1 and 1. And then we have plugged 0. So the reason behind writing the sets again is that I want to make you understand whether this example is a function or not. So now come to the point. I hope you will understand. In y, we have 4, 1, and 0. So let's write 4, 1, and 0. Now try to respond. Here, for -2, which value we have found for y? We have found 4. Is it correct?
Yes, sir.
For 2?
Yes, sir.
Yeah. So first tell me, how many values we have found for -2? 1 or 2?
One. One value.
We have found 1 value. Okay. So let's try to focus on 2. So for 2, which value we have found for y?
Sir, 4.
4.
4.
So number of output, again 1,
1,
right?
sir.
Yeah.
Yes, sir.
So let's focus on -1. So for -1, how many values we have found?
1, sir.
1, and the value is 1. But our target is to check number of values, number of output. So number of output is 1. Again, for 1, what is the output?
1, sir.
1. If I ask you how many values of y we have found for x equal to 1, we have found 1 values.
1, sir.
Similarly, for 0, how many values we have found?
So 1.
1, sir.
1. But the value is 0. So from x to y, this is the relation, no doubt. But let's have a look on the definition of function. Function is a relation. So up to now, we have fixed up that x and y, we have a relation
Function.
in between x and y. But for every input of x, there must have one and only one output, exactly one output. For every input, there must have one output. So if this condition holds, then we can say the given example is a function. So for this input, we have one output. For the second input, we have one output. For third input, we have one output. For fourth input, we have one output. For the last input, we have one output. We can also check by inputting another value of x. Let's say we are plugging 3. So whenever x is 3, 3 squared is 9. So how many values we have found? Again,
1, sir.
1. So that means for every input of x, we are getting exactly one output every time. So the comment is y equal to x squared is a function. Have you understood?
Yes, sir.
So this is our example 1. So let's talk about another example. So let's say we have y squared equal to x. So now we want to determine whether this relation is function or not. So already we have the relation between x and y. So here, let us do some algebraic manipulation. Have a look on the previous example. We had y in the left side, and on right side we have x type algebraic terms. So let's try to do these calculations. This is for our betterment. So if we want to keep y on left side, we will get positive negative root over x, square root of x on right side with positive and negative. So why we are doing this type of calculations? You know that y equal to f of x is the well-known notation for function. So that's why we are targeting for y in left side. That's why we are doing these calculations. Okay, is it clear to you?
Yes, sir.
Yes, sir.
Okay. So, and there is another question that is trickling in your mind, that why we are writing positive and negative here. So this is because we have started with y squared. So calculus is coming after algebra. So from algebra, you know that if we have x squared negative 4 equal to 0, so this is an algebraic equation. So we can easily solve x squared equal to 4, x equal to plus minus root over 4, x equal to plus minus 2. So how many solutions we have found for this algebraic equation? We have found 2 solutions. So without solving like this one, we can analyze how many solutions we will have finally for x. So this depends on the highest power of x. So here in this equation, we can easily see that we have x squared. So finally, there will be 2 solutions. Is it okay?
Yes, sir.
Yes, sir.
We can also do these calculations like factoring. So we know that x squared negative 2 squared equal to 0. So this is same as the previous equation. So now we can write x plus 2, x minus 2 equals 0. So that means x plus 2 equals 0, x minus 2 equals 0. Again, we are getting x equals negative 2, x equals positive 2. So we have totally 2 solutions. So suppose we have x cube equal to 0. You will understand that we have x equal to 0 as the solution. But we have actually 3 solutions for this equation because the equation starts with x cube equal to 0 and we are having the solution x equal to 0. But actually we have x equal to 0, x equal to 0, x equal to 0. Since 3 solutions are same, so we can write x equal to 0. But you can't remove these 2 solutions. So this is the fundamental theorem of algebra. Do you understand?
Yes, sir.
So
Yes,
that's
sir.
why y squared equal to x will give us 2 solutions for y. So now again, let's input some values of x. So we can start from 0, 1, 2. For the previous problem, we have started with negative 2, negative 1, then 0, 1, 2, 3. But here, if we input negative 1 in the place of x, you know that square root of negative 1, so this will become undefined. Okay, if you use calculator, your calculator will show error. So that's why we are not dealing with these numbers. So let's deal with 0, 1, 2. So if we input 0 where we have x, so square root of 0 will be 0. Square root of 1 will be 1. Square root of 2, so that is square root of 2. Square root of 3, so the result will be square root of 3. If we input 4, so square root of 4 is 2. If you use calculator, you will get the decimal values. So the point is, we have plus and minus before root over x. So you can't ignore this negative. So whenever we are plugging 1, what we are getting? At first plus 1 and also minus 1. Do you understand my point?
Yes, sir.
Whenever we are plugging 2, so square root of 2 with plus minus square root of 3. So plus minus square root of 3, square root of 4. So plus 2 minus 2. So that means if we try to make this diagram, then it is easily visible. We have x, y. So we have taken x as 0, 1, 2, 3, and 4. So for 0, we have found 0. So how many solutions we have found
One,
for
sir.
0? 1. So up to now, we can say that it is going with the definition of function. For this input, we have one output. But don't forget that in our definition, we have mentioned every. So not only the first input, all input, every input should have one or only one output. So let's think about the second value of x. So 1 corresponds to +1 and -1. So this time, how many solutions we have found?
So 2.
2. So this is a contradiction with the definition of function. We don't need to check the later values. We have understood that this is not a function because for this input 1, we are getting 2 outputs. So this is the contradiction. But still, we have the relation between x and y, but this relation is not a function. So we can say that y squared equal to x is not a function. Do you understand my point?
Yes, sir.
Think about 4. So for 4, we have found 2 values, +2 and another one is -2. So just to be a function, we must have one output. But for this example, we are getting 2 outputs. So this is not a function. So I hope you have understood what function is. So function is the basement of differential and integral calculus. So that's why I have started from the very beginning. So now come to the classifications of function. So here y equal to f of x. Let me write in this way. So this is the common notation for function. Here we see 2 variables. First one is x and the second one is y. So you already have understood that x is the input and y is the output. So in mid-18th century, mathematician Leonhard Euler, was the first who conceived the idea of function and tried to write function in letter notation. Okay, but before that, function was thought to be, let's say, a program where inputs are coming and we are getting outputs. But it was Leonhard Euler in mid-18th century, Swiss mathematician Leonhard Euler, this is pronounced as Euler, not Euler, Euler. So mathematician Euler conceived the idea of function to be like this, y equal to f of x. So now we can understand that y equal to f of x is the common notation of function where x is the input, y is the output, and we have f of x. So let's talk about the classifications of function because in differential calculus, these things are important. So function can be classified in many ways. So the first classification is polynomial function. So what is polynomial function? For example, Suppose we have f of x equals x squared plus 5x plus 6. So this is a polynomial function where we have the algebraic terms. Let's say we have another function g of x equal to 2x cubed plus x. So this is another polynomial function. Polynomial functions have also some classifications. This one is called the second degree polynomial. This is called the third degree polynomial. So I will come to these classifications later, but for now, let's talk about all the classifications of function. So after polynomial function, we can think about radical function. So what is a radical function? The function where square root is involved. Let's say we have y equal to square root of x. So this sign, square root, this symbol square root is called the radical symbol. You can easily understand that the symbol is just like the small letter r. So that's why you can easily understand that from where it originates. So square root symbol comes from the letter r. So that's why we know now it is as radical function. So the examples of radical function will be y equal to square root of x, maybe f of x equal to square root of x negative 1. We may also have square root of x squared plus 5x plus 6. So these are the examples of radical function. Let's talk about the third classification of function. It is rational function. So what is rational function? Rational function are the functions where we have f of x over g of x type form. That means f of x is a function, g of x is also a function. We have numerator over denominator. Here, the numerator function will be polynomial function. The denominator function will also be a polynomial function. But whenever we have this division form is also called quotient. So this is now called the rational function. For example, suppose we have f of x equal to x squared. So you can understand that the upper part, the top part is one polynomial function like this. So x squared over x negative 1. So we have two functions, the top one and the bottom one, the numerator, the denominator. So whenever we have this ratio, this is called not polynomial function. This is called rational function. So do you get my point?
Yes, sir.
Okay. So after polynomial, radical, rational, we may have other classifications also, that is exponential or logarithmic function. So what is exponential and logarithmic functions? Let me show some examples. Y equal to e power x. So you can see that e power x, y equal to e power negative x, y equal to a power x, y equal to 2 power x plus 1. So all these examples are the examples of exponential function having exponent at the power. So this is called exponential function. Logarithmic functions are y equal to log x, y equal to natural log of x, y equal to log x squared. So these are the examples for logarithmic function. So after exponential and logarithmic function, you have to know about absolute value function. So what is absolute value function? Let's say we have y equals mod x, y equals modulus of x negative 1. That means having this symbol with x type form is generating a function that is now known as absolute value function. For example, f of x equal to modulus of x plus 1 plus modulus of x negative 2. So this is one absolute value function. We may also have f of x equal to modulus of x. So you know that inside modulus, we may have positive quantity, we may have negative quantity. So always the output will be positive. You know the property of absolute value function. So negative 5 with absolute value will give us positive 5. Absolute value of 5 will give us 5. So this is the property of absolute value function. So for now, let's say we have x negative 1. So this is a function which is called absolute value function. And after absolute value function, we can think about piecewise defined function. So piecewise defined function. So what is piecewise defined function? Let me show some example. Suppose we have f of x equal to x, and then we may have e power x, we may have, let's say, x squared over x negative 1. This time we have some restrictions. So let's say the first part is defined for x less than 0. The second one is for 0 less than x less than 1. And the third one is for x greater than 1. So this time you can see that the values of x are defined. So actually x values are called domain or input variables or independent variables. So here we have actually three parts. First part, second part, and third part. This function f of x has three parts. This is the first piece, second piece, third piece. All three pieces are defined for some intervals. So that's why this is called piecewise defined function. So in limit and continuity chapter, you will see some examples that are from piecewise defined function. After piecewise defined function, you can think about another classification. So it will be so I am extending here. It will be trigonometric function. In short, trig function. And then we have inverse trig function. inverse trig function. So what is trigonometric function? Let's say we have y equal to sine x, y equal to cosine x, y equal to tangent of x. So sine, cosine, tan, cotangent, secant, cosecant. So you know all these things are called trigonometric function. Inverse trigonometric function. Suppose we have y equal to inverse sine of x, y equal to inverse cosine of x. So sine inverse, cosine inverse, let's say we have secant inverse x or x plus 1, secant inverse x plus 1. So these are called inverse trigonometric function. So these are the classifications of function. So besides all these functions, we have some more functions like inverse function. You have to know about composite function. Let's say we have y equal to x plus 1. So this is going with y equal to f of x. So if we target for inverse function of this original one, what we can do? We have to do some calculations. Is it possible to solve the previous function or equation for x? Yes, it is possible. We can keep x on the left side. So let's say we are writing x plus 1 equals y, and then x equal to y negative 1. So now you can see that we have found a relation for x. So this is the inverse function. Let's say we have y equal to f of x. If we can write x equal to f of y, so x equal to f of y is the inverse of y equal to f of x. But every function has the input as x, but here you can see that in the parenthesis we have y. So in the next step, we can input y as x. So where we have y, let's input x, that is x. But since it is the inverse of the original one, so we are writing f inverse x. If we have a function f of x, its inverse will be f inverse x. So at this part, x equal to y minus 1 can be written as x equal to f of y. But in next step, we can also write as x negative 1. Besides inverse function, you have to know about composite function. So what is composite function? We know that y equal to f of x. This is the common notation for function. So somehow you may have some functions where inside the parenthesis we can think of another function. So that function is called the composite function. So composite functions are denoted as f composite z or g composite f. So this is one open circle, but actually it is called composition. So you have to know about composite functions. Suppose we have x plus 1 and let's say this is y1 and y2. We have x squared. So y1 can be also written as f of x. So f of x equal to x plus 1. So, or for better understanding, let's write x squared negative 1. So if I look for f of x as f of x squared negative 1, so see, we are going to find another new function. That means we are going to input x squared negative 1 where we have x. in the original function. So where we have x, input x squared negative 1. So that is x squared negative 1 plus 1. So that means we have generated a new function. Let's do some calculations. X squared negative 1 plus 1, that is x squared. So f of x squared negative 1 is becoming x squared. So this is called composite function. So composition between y1 and y2. We can say this is f of x, this is g of x. So this is composite function. Besides all of these things, we also have 1 function, on 2 function. You need to know all the terms that you have in function. But function is not our main task. Our task is to know about differential calculus in this course. So that's why the first topic that we have in differential calculus is limits and continuity. More specifically, we have to know limits first, then we can go for continuity. Let's talk about limits. Whenever the term limits is coming to our mind, you can think about limit x approaches a, f of x. So that is going to be a finite number L, or this limit may not exist. So this is the notation for limits. But we have to know why limit is important. So the first point is the importance of limit. Let me discuss about the importance of limit. So limit is the building block of calculus, both for differential calculus and integral calculus. You know that calculus has two branches, that is differential calculus and integral calculus. So without limit, we can't think about calculus. So that's why limit is the fundamental building block for calculus. Now we are going to talk about limits. So you will get the intuitive idea of limits from here. So let's say we have f of x equals x squared. So already we have learned that this is a function, because just before discussing this point, we have checked whether y equal to x squared is function or not. So we have seen that y equal to x squared is function. So that means now we can write y as f of x. So f of x equal to x squared. So that's why f of x is a function. So here, whatever we have done so far, we are using the same concept. We are inputting the values of x, and then we will get the values of y. So let's say we are plugging -1, 0, 1. So for -1, we will get 1. For 0, we will get 0. For 1, we will get 1. For 2, we will get 4. So that means for x equal to 2, we are getting y equal to 4. So that means the same thing can be thought to be using the concept of limit. So what is the value of f of x when x approaches 2? So the value of x when x approaches 2. So it is no doubt that f of x will be 4, because y equal to f of x. We can write, that means limit of f of x as x approaches to 2. So that is equal to 4. Same thing has been written in a new notation using the notation of limit. Think about the same example for these values. That means we have limit of f of x as x approaches to -1. So what is the value? Have a look on the table.
Sir, 1.
1. So thank you. The value is going to be 1. That means we can calculate by this way. Limit of f of x is x squared. So this is equal to -1 squared. That means where we have x, we are plugging -1. This is going to be 1. So you can see that limit of f of x at x equal to any number -1 is going to be a finite number 1. So that means in general sense, we can say limit of f of x when x approaches to a may become finite. So that finite number is written as L. So this is the notation for limit. So whatever example I have given here, that is a defined function, that is a polynomial function. So for polynomial function, limits are always defined. Limits always exist. But for some cases, for some functions, limit may not exist. So now there is a term that is called existence of limit. Existence of limit. So limit may exist, limit may not exist. So in that case, we can say limit does not exist. So now we have to know when limit exists and when limit doesn't exist. So every time the notation will be same, limit of f of x when x approaches to a. If it is finite value, then limit exists. But limit of f of x when x approaches to a becomes infinity, or we can say plus infinity, minus infinity, anything. So in that case, we can say limit doesn't exist. So actually, infinity is not the proper term here. We can say limit does not exist. Existence of limit is important. Limits may exist, limit may not exist. If limit becomes a finite value, so we can say that limit exists. If the limit is not finite, we can say limit doesn't exist. So in differential calculus, limit is important, and also in integral calculus, limit is important. So let me give you one example. Let's say we have a curve like this. We have a function like this, f of x, and we have 2 points. The point is here and here. So from the concept of geometry, we know that joining these 2 points, we will have a line. So that line is called the secant line. So whenever we are joining 2 points that are on a curve, we say that that line is called the secant line. Let's say the first point is P and the second point is Q on Cartesian coordinate system. X-axis, y-axis are here. Now the point is, what is the case when Q is coming closer and closer to P? That means, suppose Q is here, now Q is here, and Q is here, Q is here. So finally, what will be the case? That means the line every time joining P and Q will become closer and closer to P.
Yes, sir.
So this is called the definition of derivative. That means in that case, you will see that the point P and Q are same, and the line that is denoted as the secant line will become a single line here, but this line will touch only this single point. So whenever we are joining 2 points, that is called secant line. And finally, whenever we have a line that is going through only with a single point, that line is called the tangent line. So from the concept of geometry, you know that what is slope. So slope can be thought to be m equal to tan theta. So any line can be written as y equal to mx plus c. So where m is the slope, so that is also called the tangent. So whenever q is approaching to p, q is getting closer and closer to p. So this is called the derivative. That means the slope of the tangent line at p is equal to the derivative. So here you can see that q is approaching to p. So the concept of limit is important. So this is how limit is useful in differential calculus, because in the definition of derivative, you have the concept of limit. Similarly, we have another branch of calculus. So that is called the integral calculus. So here, how limit is working, let's see. So suppose we have two vertical lines here, x equal to a, x equal to b. From concept of geometry, you know, x equals a are the vertical lines and y equals b are the horizontal lines. Suppose we have a curvy region. The region is bounded from x equal to a and x equal to b, and we have y equals f of x here. So this time f of x is like a curvy function, and our target is to find the area above x-axis to this curve. So how we can find? So this is a big question. We can think about rectangles, because we know that if we have a rectangle having length x and width y, we can say area is x times y. So we can think about rectangles here. Let's say we have this big rectangle, then we have this rectangle, then we have this rectangle, and finally we have this one. So you can understand that we have somehow found the area of the curvy region, but we are getting some extra parts and some blank part. So how can we reach to the exact area? We can add up this area 1, area 2, area 3, area 4. So this is how we can add and find the total area. But that area is not exact. Just to have the total area, we can think about more and more rectangles instead of these 4 rectangles. So instead of these 4 rectangles, now we can think about, let's say we have some more rectangles. So area will become more and more closer to the exact area. And these things will be just exact to the main area if the number of rectangle becomes infinity. If the number of rectangle that we are thinking goes infinity. So limit n tends to infinity. We can think about like this way, or we can think like we have the width here. So if this width becomes 0, that means let's say it is delta x. So if delta x is possible to make 0, then only it is possible to get the exact area, and then you will get the entire area of the curvy region going from x equals a to x equals b, this one. So we will get the total area if number of rectangles are infinity. So again, the concept of limit is helpful. So this example is for integral calculus, and this example is for differential calculus, where the concept of limit is acting as the building block, fundamental block for calculus. Now let's get familiar with some terms. One-sided limit, two-sided limit, overall limit. So these terms are important. So normally limit of a function f of x is denoted like this way: limit of f of x when x approaches to a. We can also pronounce like that: limit x approaches to a, limit x tends to a, limit x goes to a, but not x equal to a. So this is one warning. X approaches a is not like x equal to a. So remember. So any limit can be subdivided into two categories, from the left and from the right. So limit x approaches to a minus f of x, limit x approaches to a plus f of x. So here you can see that I have written positive and negative. These are not powers. These are acting as superscript. So here positive and negative are just denoting the directions. So let's say we have a number a. So coming from the right side is known as a plus. Coming from the left side is known as a minus. So you will understand by this way. Suppose we have a number line. So here in number line, we can think about a number, let's say 1. So on the right side, we have 2, 3. On left side, we have 0, -1, -2. So if we try to come from right side towards 1, so this is called 1 plus. If we try to come to 1 from left side, this is called 1 minus. So that's why plus and minus are just the directions. It's not like a negative, a positive. This is not the same thing. So these are just the directions from right or left. We can separate a limit into two parts, that is left hand limit and right hand limit. So these are the mathematical terms. In short, we can write this is left hand limit and the second one is right hand limit. So I have mentioned that limit may exist, limit may not exist. So here x tends to a or x approaches to a can be thought to be x approaches a plus, x approaches a minus. So let's come to this part, then you will understand the full criteria of existence of limit. So limit will exist if left hand limit equals right hand limit. Then we can say limit exists. You will understand if I show you one example. But here, please try to understand the theoretical part. So limit of a function f of x will exist if left hand limit, that is x approaches to a minus f of x, equals limit x approaches to a plus f of x. That means if left hand limit and right hand limit are same, then we can say limit exists. So these two things can be combined, and now we write limit x approaches a by dropping negative and positive signs. We are combining as a single limit. So limit x approaches a f of x, that is going to have the existence criteria. So whenever limit exists, you can understand that at that time left hand limit and right hand limit are equal. So for some functions you can directly find the limit, but whenever you will have piecewise functions, then you need to come from the left part and from the right part. So you can understand what is piecewise defined function. I have already mentioned that piecewise defined functions are like this, having 3 parts or 2 parts. That means more than 1 parts with some intervals. So that functions are called piecewise defined function. And for piecewise defined function, you may have to find the left hand limit and right hand limit. Suppose we have a function f of x equals x plus 1, then x, and we have, let's say, sine of x. The first part is defined for x less than 0. The second one is for x greater than 0. And the third one is for x equals 0. So we have a piecewise function. So for simplicity, let's say we have only 2 parts for now. It will be easier for you to understand. So we have a piecewise function that is defined for x less than 0 or x greater than 0. So if I ask you find the limit of f of x when x approaches to 0. So this is our target. The question may be written in an alternate form that determine whether the limit exists or not. Which limit? The limit of f of x when x approaches to 0. So the two questions are looking different, but actually the solving technique is same. If limit exists, then that value will be the main limit. So first of all, we have to check whether limit exists or not. That means we have to find left hand limit and right hand limit. So here we are looking for this limit. That means you know that x approaches a. So here x approaches 0, f of x. So you know that any limit can be broken into 2 pieces, right? Limit of f of x when x approaches 0 negative. That means coming from the left side of 0. And another one is limit of f of x from the right side of 0. So let me show you from number line. So we have the number 0. 0 plus means we are coming from the right side, and 0 minus means we are coming from the left side. Okay, so let's try to evaluate these two limits. So in short, limit f of x when x approaches to 0 minus is known as left hand limit, and for 0 plus it is right hand limit. So limit will exist if left hand limit and right hand limit are same. So let's try to find. So here limit x tends to 0 negative, f of x. So I have mentioned that the negative and positive signs are just directing the functions, are just the directions. So this is an example of piecewise defined function. So how many pieces we have? We have total 2 pieces, right? So we need to understand which function can be placed here and which function can be placed here. That means we need to locate the suitable function for 0 minus and 0 plus. Do you get my point? Please try to respond.
Sir, can you repeat, please?
Here, f of x for 0 minus. So we have total 2 pieces, x plus 1 and x for the main function f of x, right?
Yes, sir.
Yes, sir.
So since 0 minus is present, so out of these 2 functions, one function is for 0 minus. So just try to find that function. Which one is 0 minus?
x1 plus.
Yeah, x plus 1 is for 0 minus. Because here we have x less than 0, right? That means we need to find the left-hand function and we have to find the right-hand function. Do you get my point? Please try to understand. Otherwise, whenever we will come to some advanced problem, then it will be a difficult thing. So which function is the leftward function? Let's say we have leftward function and rightward function. So out of these 2 pitches, which one is the leftward function? X plus 1 or x?
Sir, x plus 1.
X plus 1. And which one is the rightward function?
Sir, x.
X. Because we have this restriction depending on x greater than 0, depending on 0 plus or x greater than 0, we can understand that the second piece of the main function is the rightward function and the first piece of the main function is the leftward function. So we have collected 2 informations, that is x plus 1 is the leftward function and x is the rightward function. So now we have to input that functions here. So you can see we are finding left-hand limit. So obviously we are going to input leftward function. So here we will input x plus 1. So we need to input the function f of x, but we have total 2 pitches. So that's why x plus 1 is written here depending on the negative sign. Do you get my point?
Yes, sir.
So this negative is just for the direction. So we have found our main function, that is x plus 1 is the leftward function. So now we can drop this negative sign. We can drop this negative sign or skip this negative sign. So now we are going to input 0 where we have x. So 0 plus 1 is becoming 1. So left hand limit is 1. So let's check what is the right hand limit in the same manner. So here we need to plug the function. So which function can be plotted here?
Sir, x.
X. Yeah. So the function x
I
is
think it will
written.
be 0.
Yeah, it will be obviously 0. So since we have found our target, we have reached to our target, that's why we can drop or skip this plus sign. So now we can input 0 where we have x. So actually we are getting 0. So left hand limit is 1, right hand limit is 0. So now tell me that left hand limit and right hand limit are the same? Can we
No,
write
sir.
equal?
No,
No.
sir.
So this is not equal. That means this left hand limit and right hand limit combinedly we have to find this one. So this one is not existing. So we can say the main limit x tends to 0 for the main function, for the main piecewise function is not existing. Let's say limit f of x when x approaches 0 doesn't exist. So this is one example from limit. Limit will exist only when left hand limit and right hand limit are same. Okay?
Okay, sir.
And before this one, I have mentioned that limit will exist if the limit is finite value. So you can see our left hand limit is 1. This is a finite value. So left hand limit exists. Right hand limit is 0. It is also finite. Right hand limit also exists. But
But they are not equal.
yeah,
Not
but
same.
left hand limit and right hand limit, since these two are not same,
So that we call that it is, does not exist.
doesn't exist. So despite left hand limit and right hand limit are finite, the main limit doesn't exist because left hand limit and right hand limit are not same. So limit doesn't exist for this function. Do you get my point?
Yes, sir.
So since only left hand limit exists, since only left hand limit is finite, only right hand limit is finite, so we can say that this is one-sided limit and this is another sided limit. So left-sided limit exists, right-sided limit exists, but the overall limit doesn't exist. That's why I have written these three terms. So these three terms are denoting that things. That is one-sided limit, maybe only left-hand limit, maybe only right-hand limit. Whenever we are finding both left-hand and right-hand limit, that can be called two-sided limits. If both limits are same, we can say the overall limit exists. So left-hand limit equals right-hand limit. So you will understand again if we have a look on some more examples. Suppose we have a function f of x as absolute value of x. So, you know, having absolute value is denoting the modulus. So, this is one absolute value function, but absolute value function can be made into piecewise function. How we can make? You know that inside absolute value, the quantity that we have may be positive, may be negative, right?
But the result will be always positive.
The result will be always positive. Yeah. So we can think about all numbers, all real numbers for x. So that's why I'm drawing the real number line 0, 1, 2, 3, -1, -2, -3. So this is our x-axis. So we can make this one as piecewise function. How we can make? We can think about, let's say this is our 0 and here we have 0 plus, here we have 0 minus. So we can first make some assumptions. X less than 0, then x equals 0, and finally x greater than 0. So what will be the case if x is greater than 0? Then it will be positive x. Just we are thinking about the inside quantity. If x equal to 0, then let's input 0, we will get another piece, that is 0. If x is less than 0, so what will be the case? The inside quantity will be negative x. So this is how we can break down an absolute value function to a piecewise function. So why we are targeting for the piecewise function? Piecewise defined function is very important for finding the limit. Now we have found f of x as this. So our question is whether limit of the function f of x exists at x equal to 0. In short, when x approaches to 0. Question is determine whether limit f of x when x approaches 0 exists or not. We know the existence criteria, that is if left hand limit equals right hand limit, then we can say limit exists, right?
Yes, sir.
If left hand limit is a finite value, if right hand limit is a finite value, then we can say left hand limit exists, right hand limit exists. And if both limits are equal, then we can say the overall limit is finite and exists. So just for now, suppose you are finding the left hand limit and left hand limit is becoming positive infinity. So does left hand limit exist? No. So that means we don't need to find this one. So the overall limit will be infinity. That means overall limit will not exist. So our target is to find the limit of f of x. So let's break down f of x when x is approaching to 0. So every time we can break into two pages, that is left hand limit for 0 minus, right hand limit for 0 plus. So let's denote for our simplicity, that is it is left hand limit and it is right hand limit. So whenever we have generated these relations, now the thing is we have to understand which function is 0 minus, which function is 0 plus. Otherwise, you will not get the exact answer. So we have actually three functions here. So can anyone tell me which function is the leftward function, which one is the rightward function, and which one is the equal function? So let's say I am writing L, R, and E. So x less than 0. X less than 0 means 0 minus. X greater than 0 means 0 plus, right?
Yes, sir.
Yes, sir.
So x less than 0, that means the corresponding function is leftward function. X greater than 0, so the corresponding function x is rightward function. So let's write, we are collecting the information. So left hand function, leftward function will be negative x, rightward or right hand function will be positive x. Since we have x equals 0, so for now let's denote this corresponding function as e, that is equal function. So for limit, we will not be working with e, that is equal function, but whenever you will go to continuity term, then this part is important. So it's better to practice from the very beginning always try to find left function, right function, equal function. Okay, so now this is easy to calculate. So limit x tends to 0 negative. So which one is leftward function or 0 negative function? Minus x or 0. You can easily see that negative x. So since this minus is just for the direction so that we can find the exact leftward function, and now we have found negative x as the leftward function, so there is no need to write negative sign, so we can drop. Okay, so now this is the time to input this limiting part where we have x, so we can input 0, so negative 0 means 0, negative x, negative 0, that means we are getting 0. Okay, done. Similarly, for right hand limit, we have to find the rightward function. So, or we can say 0 plus function. So 0 plus function is positive x. So now there is no need to keep plus sign. This is just for direction. So input 0. So we have 0. So 0 is a finite value. On right side, 0 is also a finite value. So we can say that one-sided limits, that is left-sided limit, right-sided limit are existing. That is left-hand limit is 0, right-hand limit is 0. Both these two limits are same. So we can now say, since left-hand limit equals right-hand limit, therefore the main limit, that is the overall limit, exists. That is this one, what we are targeting for. That is limit f of x when x approaches to 0 actually exists. That means, let me write in this notation, the main function that we have is modulus of x, is absolute value of x. That means in some textbook you will see this type of notations, that is the function is here. So limit of absolute value of x when x approaches to 0 actually exists, right? So there is one warning, that from here you can easily find left hand limit and right hand limit without converting this one to piecewise function. Then every time you will see 0 and 0. That is also okay, but this is not same for all cases. So please try to convert the absolute value functions to piecewise function. Then it will be easy to find leftward function, rightward function, and equal function. Okay?
Okay, sir.
Okay, so this is whatever is called limit, existence of limit. Now you can see that we have another function e inscribed in the main function. So what is about e? So this e, that means equal part, will be helpful for continuity term. So by that time, if you have understood that how we can find limit. So since limit of modulus of x tends to 0, that means we can say limit of modulus x when x approaches 0 is equal to 0. First of all, we have to find the left hand limit, right hand limit. If both left hand limit and right hand limit are same, then we can see that the total or overall limit is same and have the same value, 0, 0, 0. So that's why we say in general limit f of x when x approaches to a is L. in some textbook, you will see the same notation is written in an alternate form. F of x approaches L when x approaches A. That is, f of x approaches L as x approaches A. So this is what we know now as limit. Now come to the point continuity. So what is continuity? Remember, we are dealing with functions. The function may be polynomial function, it may be radical function, it may be rational function, trigonometric function, absolute value function, exponential or logarithmic function, anything. But the main thing is we are going to find limit, and now we are going to find continuity. We are going to check whether a function is continuous at x equal to a or not. So what do you mean by continuous function? Suppose we have a function like this. This is y equals f of x. So the curve is starting from here and now it is going to this part. So you can see that without lifting my pencil, I can draw a smooth curve. So I haven't lifted my pencil up. That means I am starting from here without lifting my pen or pencil. I am going forever. So this is a continuous function. But on Cartesian coordinate system, if we have a function like this, let's say I am going to draw a function without lifting my pencil, and at some point I have lifted up my pencil, and now we are going forever. So you can see that there is a disconnected portion. So this disconnected portion is called the discontinuous part. So the function that we have drawn here is not continuous. So this will be discontinuous function, and this will be continuous function. Do you get my point?
Yes, sir.
Yes,
So
sir. Yes, sir.
for the continuous curve, let's say here we have a value. So it is found for some x equal to a. The discontinuous part is found for, let's say, x equal to a. So for x equal to a, the function may be continuous, the function may be discontinuous. So the real life examples of continuous functions can be, let's say, a man is throwing a ball. So let's say a tennis ball. So the path of the tennis ball, that means the trajectory that the ball will have, is a continuous function. Suppose a man is throwing a ball from here, and after some distance it will come here. So this path is an example of continuous function. Suppose we have two posts here where electric cables are hanging. So this is one continuous function. So the hanging cable is not a polynomial function, is not a parabola, especially it is called catenary. You will learn about catenary if you search on Google. So what is catenary? You will understand. But the thing is, you have to understand what is continuous function. That means electricity is going in a continuous way. So these are the examples of continuous function. So now we have to understand the main definition of continuity. So how continuity can be described? Again, continuity is based on limit. So a function f of x is continuous at x equals a if left hand limit equals right hand limit equals functional value at a. So now you can easily understand that you know about this one. You are familiar with left hand limit and right hand limit. If left hand limit and right hand limit exist, that means if left hand limit and right hand limit are equal, so we say that limit exists. So this is the criteria for limit. This is the definition for limit. But with this definition, we are adding another condition. That means with left hand limit equals right hand limit, also we have to check the functional value f of a. So if all the three conditions are same, so we can say limit exists and the function is continuous at a. Do you get my point? Do you understand the definition of continuity? So this is the theoretical concept. Okay, so let's talk about some examples. Suppose we have f of x equals x squared plus 1. We may have one. We may also have, let's say it is 2. We may also have x plus 1. So we have a piecewise function. X this is for x less than 0. Let's say it is for x equals 0 and it is for x greater than 0. So we have written one function. Okay. Now the question is check whether f of x is continuous at x equals 0 or not. Do you get the question? Check whether f of x is continuous at x equal to 0 or not. Is it clear?
Yes, sir.
So
Yes, sir.
for continuity, what is our condition? Which condition we should check? We have to check whether left hand limit and right hand limit are same or not. If these two are same, we have to also check about f of a. So here, if we compare with x equals a, so what is the value of a? What is
0.
the value of a? 0. So that means we have to find left hand limit at x equals 0. We have to find right hand limit at x equals 0. And we have to also find f of 0. So you will see this type of problems in your textbook. You can go through any one. My suggestion will be just try to have a look on calculus written by Howard Anton. So this type of problems will be given in assignments very soon. So the way I am going to solve, you can solve in this way. So Our target is to find left hand limit, right hand limit, and functional value at 0. So just like the previous problems, we need to find which function is the leftward function, which function is the rightward function, which function is the equal function. We can understand that there are 3 pitches here. So that's why it is called piecewise defined function. So which one will be the leftward function? Obviously, x squared plus 1. So we are collecting this information because it is important. Since we have x greater than 0, so it is the rightward function, x plus 1. For x less than 0, x squared plus 1 will be leftward. And we have x equal to 0. That means for x equal to 0, what we have? We have 2, right?
Yes, sir.
So these are the
Yes, sir.
informations you have to collect first. Otherwise, it will be difficult to go ahead. For continuity, all conditions must have to be same. Suppose left hand limit and right hand limit are not same, so the function is not continuous. If left hand limit and right hand limit are same, but functional value is not same, so the function is not continuous. If left hand limit and functional value are same, but right hand limit is not same, so the function will not be continuous. But if only the 3 conditions are same, then only we can say the function is continuous. So let's see what happens. We are targeting for limit of which function? F of x at which number? X tends to 0, right?
Yes, sir.
So now we can break down this limit to 2 pieces. That is, x approaches 0 minus f of x, when x approaches 0 plus f of x. So you already know that these are called one-sided limit. So this is called left-sided limit, and it is the right-sided limit. In short, you can write L is L, left-hand limit, R is L, right-hand limit. Okay. Now, for left-hand limit, we need to input the leftward function. So which one is leftward function? X squared plus 1. So here, limit x approaches 0 minus f of x will be x squared plus 1. So we have located our desired function. So that's why there is no need to write negative. Negative is just a direction to locate the leftward function. So now this is the time to input 0. So when we have x input 0, so that means 0 is squared, x is squared, 0 is squared, and we have plus 1. So we are getting 1. So left hand limit is 1. This is finite value. That means this is going to exist. Similarly, let's find right hand limit. So here, limit x approaches 0 plus. Which function is 0 plus or rightward function?
Plus 1, sir.
Yeah, thank you. So x plus 1 is our rightward function. So let's input x plus 1. So now we can drop this plus sign. So now the time is to input 0 where we have x. So let's input 0. That means 0 plus 1. We are getting 1. So left hand limit and right hand limit are same. Okay. Right hand limit is 1. So it also is a finite value. That means it is going to be exist.
Yes, sir. It also exists.
So this is left hand limit and right hand limit. So now left hand limit and right hand limit are same. So we can say since left hand limit and right hand limit are same, so limit exists. Up to now, we have found a limit, right?
Yes, sir.
Now, for checking continuity, don't forget that this time we are not finding limits. Besides limit, we are finding continuity. So besides left hand limit and right hand limit, we have to check this condition also. What is f of 0? That means x equal to 0. So when x equal to 0, what is the function? It's 2, right? That means f of a or f of 0 is the equal function. Already we have found. So what is f of 0?
So 2.
2. So here we have defined that f of 0 is 2. It is also a finite number. That means this is a defined function. It is called a constant function. It is a classification of polynomial function. Polynomial functions can be constant, can be linear, can be quadratic, can be cubic, can be quartic, can be 5th degree, 6th degree, 7th degree, up to nth degree. And this is the first case, constant 0 degree polynomial. So left hand limit, right hand limit, and functional value. So left hand limit is 1, right hand limit is found to be 1. So these are equal, but functional value is 2. So this is not equal to f of 0, right?
Sir, I don't understand
Yes.
how we get the functional value.
Okay. Just think about a function. So that means we have a constant function. Let's say 2. So actually, inside 2, we have 2x power 0, right?
Yes, sir.
You know that x power 0 is 1. Anything power 0 is 1. Although we have here some concept that is called indeterminate form. So we are not going to indeterminate form here. But for now, for simplicity, just try to understand. X power 0 is 1. So in tabular form, always we input x and then we get some values of y or f of x. So let's input 1 here. So 1 to the power 0, it will be 1. 1 times 2, it will be 2. If we input 2, 2 to the power 0, 1. 1 times 2 will be 2. If we input 3, 3 power 0, 1. 1 times 2 will be 2. If we input 100, 100 power 0,
Yes,
1.
it will be 0.
1 times 2 is 2. That means no matter what is the input, 1, 2, 3, 4. Let's say we have negative 1 power 0. Okay, it will be again 2. So negative 1, negative 2. That means if it is 1, it is 2, the function is a constant function, right?
Yes, sir.
So every time we will get 2. So that means invisibly we have x power 0, but we have just written 2. Do you understand? Do you understand? Okay.
Understand. So that's why we are written that f of 0 is equal to 2, right?
Yeah. Yeah. So this is just one example. Okay, how we can think about constant function. So suppose now in short, if you have f of x equal to, let's say 100, and you are going to input 0, what will be the result? Since it is constant, 100.
Yeah, 100.
If you input 2, it will be again 100. If you input -1, it will be again 100. So in general sense, let me write in general, that is if f of x equals c, so no matter what is the input, always you will get c. Suppose we are inputting a, it will be c. we are inputting 0, it will be C. Okay, directly you can think about.
Okay, sir.
Okay, so the question is, what is continuity? So left hand limit and right hand limit are same, but the functional value is not same. So we can say that the function that we have started with, this is not a continuous function, this is discontinuous, right?
Yes, sir.
So the comment that we can leave, the given function f of x is not continuous at x equals which one? 0. Now we can write equal. So at x equals 0, the function is not continuous. That means the limit exists, but the functional value doesn't exist. So the function is not continuous. For a continuous function, all the three conditions must have to be same. Is it okay?
Yes, sir.
So
Yes, sir.
let me show another example. This will be the last example for this session, and then we can conclude the session. So here, suppose we have f of x equals x squared negative 4 over x negative 2. This is for x not equals 0. And we have, let's say, 4, which is for x equals 0. So you can see that the constant function is 4. So if we define this one as f1 and this as f2, the first piece as f1 and the second piece as f2, so f2 is 4. So if we input f2 as 100, so what will be the value? It will be 4.
It will be
because
4.
it's an instant function, right?
Yes, sir.
Okay. So again, our target is to check whether the function is continuous or not. So the question is same. Check whether the function, check whether f of x is continuous or not. So here I have written x not equal to 0, x equal to 0. But you will check, this is a home task. You will get that the function will not be continuous. But let me write 2. That means we are going to check whether the function is continuous at x equals 2 or not. So by comparing with x equals a, so what is the value of a here? It is 2, right?
Yes, sir.
Now, whenever we are talking about limits, so right-sided limit, left-sided limit, and the equal part is coming to our mind. So here x equals 2 is present. So the rightward part will be 2 plus, the leftward part will be 2 minus. That means we have to find the rightward function, we have to find the leftward function. So you can see that the rightward part, that is 2 plus, can be written as x greater than 2. The leftward part is x less than 2. But do we have x less than 2 here or x greater than 2 here? No. That means we have x not equal to 2. This is the same meaning like x less than 2 or x greater than 2. So x not equal to 2, x not equal to 2 means either we have the right part or the left part. Either we have the x greater than 2 or x less than 2. So that means we have x squared negative 4 over x negative 2, which is defined for x less than 2 and x greater than 2. And we have the second part, that is x equals 2. So we have just written in a simpler notation. The previous function is now in a good notation. So our target is to check the continuity. So what is the condition for continuity? Condition for continuity is we have to find left hand limit, we have to find right hand limit, we have to find the functional value at a. So what is the value of a this time? 2, right? So f of 2. Clear? Is it
Yes,
okay?
sir.
So this is our target. So let's construct the limit first. Just like the previous problem, we had just the function. No limiting concept is given, but since we know the definition of continuity, left hand limit, right hand limit, functional value, so automatically the concept of limit is coming at x tends to a. So here in the given question, there is no term like limit, but we know that for finding continuity, we have to make limiting concept first. So that's why let's construct limit x tends to 2 f of x. Then 2 can be 2 negative and 2 positive. So let's try to find. This is our function. So our first target is to write the informations. So which one will be the leftward function? These are the informations we need. Leftward function is x squared negative 4 over x negative 2. Rightward function is the same one.
Yes,
Yes,
sir.
sir.
And which one is the equal part? X equals 2. So the corresponding function is 4, is the equal function. Let's construct the limit. So limit of f of x, limit of the main function at x approaches to 2. So that can be broken into 2 pieces. That is, the first one is called the left hand limit, limit x tends to 2 minus f of x. And the second one is right hand limit, limit x tends to 2 plus f of x. So here, now we need to input 2 minus function, 2 plus function. So limit x tends to negative. So which function is 2 minus function? This one. X squared negative 4, x negative 2. So we have found the leftward function. We can skip negative sign. Similarly, limit x tends to 2 plus function is the same one. That is x squared negative 4, x negative 2. So we have found our rightward function. We can skip this plus sign. Now the main part is to solve this limit. So you know that from your limiting concept. I hope you have gone through all the videos of BUX. You know, we have some techniques to find limits. We have algebraic manipulation. We have change of variable. We have L'Hopital's rule. Okay, so these things can be applied to solve this limit. So you can see that on left side and on right side, we have the same function and same limit. So if we can find the left hand limit, we can easily write the answer, same answer for right hand limit. So our target is to find limit x tends to 2 x squared negative 4, x negative 2. So how we can find? This can be found by algebraically, or we can find by L'Hopital's rule. So here we will discuss about L'Hopital's rule later in our next discussions, but for now I am showing both methods. So limit x tends to 2, x squared negative 4, x negative 2. So here the first method is algebraic manipulation. We know that a squared negative b squared is a plus b, a minus b. So now we can reduce the term, that is x minus 2 in numerator and x minus 2 in denominator are same. That's why the reduction can be, the simplified form is x plus 2 for this function. So here, now the time is to input x. So 2 plus 2. So we are getting 4. So left hand limit is 4. So this is the method called algebraic manipulation. But we have another method that is called L'Hopital rule. L'Hopital was the mathematician. His full name was Guillaume François Otto Marquis de L'Hopital. So in short, we say L'Hopital. So L'Hopital's rule. So L'Hopital's rule deals with differentiation. So since you haven't go through differentiation yet, I think we can skip L'Hopital's rule. But for now, you know that we can do this one by L'Hopital's rule. In our next discussions, we will try to solve by L'Hopital's rule. We will see how L'Hopital's rule works. L'Hopital rule mainly depends on differentiation. So first of all, L'Hopital's rule deals with 0 by 0. So here, if we input 2 initially, 2 squared negative 4, 4 minus 4, that is 0, 2 negative 2 on denominator 0. So that means 0 by 0 is coming. So 0 by 0 is called indeterminate form. We will discuss this thing later. But for now, I want to show that whatever method we will use, we will get the same result. So it's up to you. There will be no restriction in exams. You can apply any method that is helpful for you. So L'Hopital says that if the derivative of the numerator and the derivative of the denominator exist, then that result will be for the main function also. So here, limit x tends to 2. Since we are getting 0 by 0, that means we are differentiating both numerator and denominator. This is called L'Hopital's rule. So differentiation of x squared, you probably know that it is 2x. Differentiation of 4 is 0. In denominator, differentiation of x is 1. So now this is the time to input 2, where we have x. So 2 times 2 by 1, that is 4. So since this part is going to be 4, so L'Hopital's rule says that the main function has the same limit at x tends to 2, so it will be also 4. So this is what L'Hopital rule is. But for now, you are familiar with algebraic manipulation, and by algebraic manipulation, we have found 4. So what is the value of left hand limit?
It's 4.
4. Right hand limit?
It's also 4.
Also 4. So that means we can say that left hand limit is finite, which exists. Right hand limit also finite, which also exists. And left hand limit and right hand limit both are same, equal.
Yes,
So limit actually exists, that is overall limit exists. So it is not our target. Our target is to check whether the function is continuous or not. So we have found that left hand limit and right hand limit are same. That means limit exists. So for continuous function, we know that we have to check another condition besides left hand limit, right hand limit. We have to check the functional value at 2. So what is the functional value at 2? We have already found 4. That is f of 2 is 4. So since left hand limit equals right hand limit equals functional value at 2, all are same, so we can say that the given function f of x is continuous. That is f of x equals x squared negative 4 over x negative 2, and for this piecewise function which is defined for x not equal to 2 and x equals to is continuous at x equals 2. Okay, because left hand limit and right hand limit all are same. So this is what we know as limit and continuity. So I hope you have understood. So that's all from me. Thank you for joining the session. Have a good time.